Hello guys, this is a continuation for Coulomb's law focusing on one-dimension problem solving. Let us try to solve one-dimensional problem involving three charges located on a horizontal axis. For this problem, we will solve the net force on Q3 due to the forces by Q1 and Q2. We can follow this mnemonic, GIFMADS or GIFMADS. We identify the given quantities with their standard units. Identify the focus charge. Make the free body diagram of the focus charge. Compute for the forces of the other charges on the focus charge. Assign the algebraic sign, positive or negative, for the calculated forces according to their direction. Determine the direction of the net force. And finally, get the sum of the forces. For every problem-solving task, it is essential to start by noting the given quantities and ensuring they are in their standard units. In this particular problem, we need to convert the given quantities from nanocoulombs to coulombs and from centimeters to meters. The problem states is asking for the net force on Q3, so our focus charge is charge Q3. We need to identify the focus charge because it is the charge in which our FBD arrows will originate. To draw the free body diagram of Q3, let us identify its interaction with charges Q1 and Q2. Let's start with the force of Q1 on Q3. Q1 and Q3 are both positively charged, so Q1 will repel or push Q3 to the right. Remember that we always draw the arrow from the focus charge, in this case charge Q3. Charge Q2 is negative, so it will attract or pull the positively charged Q3. We now have the free body diagram of Q3. The free body diagram is very important to determine the magnitude and direction of net force. The next step is the calculation of the forces labeled in the FBD. Using the Coulomb's law equation and the given quantities with their standard units, we can calculate the magnitudes or values of the forces acting on Q3. For clarity, we label our calculated values to the forces in our free body diagram. Then, we assign negative or positive sign according to the direction of the force. Leftward and downward directions will be assigned as negative, while upward and rightward will be assigned as positive. For the last steps, we will determine the direction and the magnitude of the net force. By definition, net force is total of all forces acting on an object. So, we add to the calculated forces with their algebraic sign representing their direction. As a result, our sum will also bear positive or negative value. The negative of positive sign will suggest the direction, and the numbers will suggest the magnitude of net force. For this problem, the total net force is negative, suggesting that the force of Q2 on Q3, which is directed to the left, is greater than the force of Q1 on Q3, which is directed to the right. Try to solve this example using the process that we have discussed in this video.